Alright, in example 6.23, once again, Hawks has a great video. You jump into this video and she goes through this great explanation. She gives you this picture here, showing you that hey, if you have, let me write this stuff out. She says, hey, if you have a mean of 28 and a standard deviation of 2.5, and you're given that you have the area to the right is 0.67, she gives this great picture. I mean, like, where she goes through here and draws this thing out so that way you can really see like what's going on. Like, you can really see, hey, this is 0.67. She explains then that means that this entire thing is 1. So then we take 1 minus 0.6700, and that means that the area under the curve on this side is 0.330. Excellent explanation. Get to that point. Please watch that video, and then watch mine, or just watch this one. At this point, though, she goes in and says, okay, well, let's use our TI-84 to go calculate the z-score with an inverse norm. Inverse norm is great, and many teachers will use that. And in this case here, whereas in section 6.3, I didn't really want you to use technology at all. If you feel comfortable doing what she's doing and you understand that you're just going back and forth in the scores, please do. But what I wanted is that I wanted to make sure we understand, and that's kind of where I am. So we come here and I pull out my normal distribution table. Remember, my area is 0.33. That's less than 1/2. So since I'm less than 1/2, I need to be on the negative side. So I pull up and I'm scanning through here, and remember, I'm looking for the 0.33 inside. That's the area, that's the probability that will give me a z-score on the outside. So I come down here looking for 0.33, and let's see, 0.32, 0.31. Here we go. So we've got 0.33360 and 0.329917. Well, if I pull out my calculator to make sure like which one's going to be the best, and I say, okay, I've got 0.33360 minus oops, that's not a point, that's a decimal, 0.33. That guy is 0.036 away. Make sure I typed everything in right. Yep. And then if I did 0.33 minus 0.32997, now we've got to translate what that means, because that is scientific notation, but that's okay. So what that's basically saying to is that's saying that if I have 3e to the negative fifth, that's 3 times 10 to the negative fifth. So that basically means I have 3, and I take my decimal and I move it 1, 2, 3, 4, 5. There's where my decimal goes, and I fill in that space with zeros. Point being, this difference is way smaller than that difference, so this guy is going to be the one that I'm going to go with because he's closer to what we had, which was 0.33. Alright, so that's kind of how you make that decision. So what does that mean for us? Well, that means that our z-score, we take this guy, we cruise over, we've got 0.4. We take and we cruise up the table. So let me draw my line so we make sure. So we're cruising up the table going this way. But I got to pull it up so we can see. So that would be a negative 0.44. So our z-score is going to be negative 0.44. So I roll on back to the previous screen. Go ahead and pull up my little problem here. And so here we are. We find out that our z value is going to be equal to negative 0.44. Alright, so then at this point, so that was find my z value. That's step 1. So step 1 was find your z value given this area of 0.67. Step number 2 is to find my x value. So let's go back and just one page on her notes here, on Hawks notes, and recall this. So in Hawks, we talked about, we've seen the z-score. So we've used this guy before. So this is our z-score formula. Used it several times leading up to now. Basically what the z-score does is it takes a score and standardizes it. It puts it into this standard normal distribution curve where we know that in the middle you have z equals 0, and then you have your -1, -2, -3, and then +1, +2, and +3. So it's called standardizing your score, so we can compare two different sets of data to identify their relationship with the mean. So with this, we can also take this formula, because x is one of our variables inside, and we can solve this formula for x. So what we're going to do here is, this is going to be the formula that we're going to use when we're looking for an x value. Alright, so let's roll back to our page here. Jump things around, get where we need to be. Alright, so at this point we have that formula that we're going to use, and that guy is x is equal to the z-score times the standard deviation plus the mean. And so we just plug in what we know. We know that x is equal to 28. Excuse me, that's not my z-score. We know that x is equal to my z-score, which is -0.44, times my standard deviation, which is 2.5, plus my mean, which is 28. Pull out our calculator. Oops, forget I gotta use a different tool. Pull out my calculator, so -0.44, open parentheses, times 2.5 plus our mean of 28 comes out to be an x value equal to 26.9, which means that translates and says that if my mean is 28, then if my area to the right is 67% or 0.67, then this x value right here would be 26.9. Alright, so that's finding a specific x value for a set of data.